share my screen and ask the inevitable question if people can see my screen. I can't currently see the view on.
Yeah, we can see.
We can see it. Yeah.
Okay. I need now to find my notes view. Okay, I'm there. Good, good, good. Thank you very much, Meg, for facilitating this. Thank you, everybody, for coming. As I said in my introduction, I represent today the Visual Geometry Group at the University of Oxford, in the Department of Engineering Science. We're a large general computer vision research group, which increasingly means using AI. Increasingly, actually, we work not just with images, but also with audio-visual data and text. Despite being based in an engineering department, I'm not myself an engineer. My background, this is my personal webpage, is in book history. I'm a historian of books and printing who's had reason to use computer vision in the course of my work. And my role in VGG kind of comes out of that situation at the intersection of digital collections and research, also teaching. So my role in VGG is to disseminate the output of its research to appropriate communities in humanities and cultural heritage. But also, it's a two-way process. It's also to uncover research questions, find interesting data sets. Like all machine learning interested research groups, we have a voracious appetite for data, and cultural heritage organizations have lots of well-curated data. So that's of technical interest for us, as well as humanistic and general interest. And I say this because if you work for a cultural heritage organization, you should know that your data has that kind of value, and accordingly strike a bargain if you're dealing with the likes of us, or perhaps it might be a large technology company. And we also take in feature requests, requests for software and support. As part of this kind of outreach agenda, the kind of software we release publicly has moved on in recent years from these kinds of things. These are largely MATLAB toolkits, and you can see from the titles alone that they are specialized pieces of software. They're kind of forbidding academic pieces of software, perhaps. So we still do these, but we also now produce software for broader use, and you can see by the titles of these, which are much more descriptive, that agenda at work. So VGG text search, image comparator. I'm going to talk briefly about all these tools actually in the course of talking about how they interact or might interact with IIIF. Supporting that software are 3 full-time research software engineers, although actually we have a vacancy at the moment that hopefully is about to be filled. But in general, we have 3 full-time research software engineers funded under an Engineering and Physical Science Research Council, EPSRC, in the UK grant Visual AI. That means we can support the software that I've just showed until currently 2025. It's all free and open source under BSD license. We provide Docker files for some of those tools, native binaries increasingly want to produce, and to some extent we support IIIF. So currently 3 of our tools support IIIF ingest, and I'll be talking about them today. I want to use this opportunity to address the community, to ask some questions, to enlist your support. We invite from you, from the IIIF community more broadly, a critique of what we're up to already. Because we're based in an engineering department, we don't necessarily know how IIIF is being used in cultural heritage. And I well remember actually Matt, who's on the call today, introducing IIIF to some of our researchers and research software engineers at a meeting in Oxford, and making an impact, I have to say. So, but it's not something that's generally well known about in our field, but we do know, of course, from speaking with people like Matt and cultural heritage organizations, just how important it is. And certainly from my point of view, I don't think I can remember a standard within the museum world taking off as far and as fast. So we need to support it. Are we supporting it well? I invite your comments on that. Also invite any use cases for additional support, things that you think other tools as they are could support. Co-development propositions, maybe we can share some tasks usefully. And we would also very much appreciate signposting emerging IIIF standards. Which way is the standard going, or set of standards going? And can we align with that? Can we maybe perhaps even kind of propose some things that would make their way into standards? I'm not I'm not entirely sure, but it would be good to have that conversation too. So as I said, at present, we do have a level of IIIF support. We have that in these three tools are a text search tool, which spots text in the wild and does OCR, a face finder, facial finding and recognition engine, and our image classification tool. And on the right is some code authored by my former colleague. He just left the group, a former research software engineer, Ernesto Coto. It's just a bit of code for downloading images and metadata from a IIIF manifest or a collection URI and ingesting the contents into the classifiers on the left. I'm going to showcase, first of all, Vic, also produced by Ernesto and RPI and Andrew Zisserman, a VGG image classification engine. To demonstrate what it does, I'll just quickly show an implementation of it, although actually this implementation precedes the launch of Vic as public software. So this is a collaboration we did with the organisation Art UK, or a digital collection of large numbers of originally oil paintings. It's broadened now, but originally it was oil paintings in public ownership in the UK. It's up to around about 200,000 paintings, and we provide a means by which a classifier can learn features from photographs on the internet and then extract paintings that have those matching features. So we train on photographs and search retrieve from paintings. The kind of flowchart of images looks something like this. So it's a slightly complicated diagram, but if I can go through that. So this happens on the fly, and in the middle we have a actually, this part precedes ordinarily the on-the-fly search, but in the middle we have a box representing the Art UK corpus, paintings for retrieval, which we process with a CNN, convolutional neural network. What we do on the fly is ingest images from, we use Google Images in this case. We can use local images, we can use images from other sources on the internet. We use Google Images as a convenient source of tagged images for training, or rather refinement of training, because the classifier we built has been pre-trained. It's been pre-trained on ImageNet, but we refine with images grabbed from Google, which are processed with the CNN. We can, if we like, also provide negative training examples per each search. They have to, of course, be specific to each search. So at the bottom, you can see some images that are not relevant to the query, which in this case is beard, which has retrieved images with men with beards, which we then apply to the encodings, the features extracted from Art UK, and retrieve men with beards, or it might be ships, or no, this is boats actually. You know, the standard kind of slightly simplistic single word labels that neural networks have lately been much better at retrieving than other methods have been in the past. More complicated images, more ambiguous images are fascinatingly difficult and thought-provoking to deal with. Perhaps more kind of serendipitously, we also kind of search on colors here, so chartreuse, and then textures. This is particularly suggested to me. I want to see that this kind of cobweb feature showing up in diverse contexts, you know, kind of nice way of browsing the collections, but also kind of making the point that the features that these systems work in are somewhat abstract, even if they're organized into coherent shapes humans. You know, these classifiers can work on other forms of visual features than you know, well-rounded objects, animals, inanimate objects, or so forth. Okay, so this is some of the documentation in Vic of how to search your own image data sets from a IIIF repository, which is a feature that is, I want to say, just 2 years ago. I'm just going to tab to my Chrome and demonstrate that. So if I can not hit the call, I will find. Possibly, oh no, it's because I have the Zoom meeting there. Okay, phew. So here is a classifier. Here is the interface for an instance of Vic running on locally on my system. And if I just go to the back end, you can see that we have the ability to, we have Google selected here as our image search engine. In the back end, I can provide images for ingest either locally Or much more conveniently, I can select a local IIIF manifest or the URL of a manifest specifying the files, which I've already done. So if I go back to the front end, show you the interface, we have the ability to search by image, either by upload or pasting image URL, or by metadata. And I'm going to just show that because it's the most convenient way to get an overview of what's within a IIIF collection. In this case, this is a collection URI, not a manifest URI. So if I do a wildcard search, I can see the contents of this is Villanova Digital Libraries collection, and there are some broken links here. But what I can do, among the things I can do, is do a similarity search on any one image. So I'm going to do a similar search on this image here, which retrains the classifier and quickly comes up with, the usual mixture of more or less accurate, in some cases highly accurate, highly relevant, and interesting, but not necessarily specifically what we're looking for, but related results. And as you go down the list, you find things that are maybe suggestive of certain qualities, sort of round qualities, leaves, things like that, but are not within the bounds of a single classification, perhaps. Now, just to demonstrate this is indeed IIIF, if I click on image myself, I can see that I have the metadata, a lot that's gone along with the image in the manifest, and everything in copyright rights, and importantly, a permanent link back to Villanova to look at that item in its own interface. It takes a minute to load. I guess this is mirrored all right. I get confused. Some more 10 more feet, isn't it? All right, so that is the basic operation. In summary, this ingest functionality is really convenient for teaching purposes. So instead of pointing people to large image repositories, or at certain times we've handed out USB sticks with data on, we can just provide them a single or one of a number of URIs that they can choose from, and they can get everything in one step. It also usefully showcases computer vision's ability to work across multiple collections, to bridge collections and find new associations between materials that may have different metadata or different metadata and different digitization standards applied to them. And like I say, it's useful and in a way, I think, kind of correct from a professional, ethical, and critical point of view, as far as in relation to provenance of data, that both metadata and images are processed together and displayed in the same view. Weaknesses of this level of IIIF integration is it does not leverage the image API, as in the thing that people perhaps most obviously associate with IIIF, as in the Villanova digital library viewer that I just showed, and everything that goes with that in terms of very nice user interfaces, levels of zoom, and so forth. We don't provide that in the front end, as you saw when I was browsing through items in the library. Users have to ingest whole manifests or collections one at a time. And what we need is something perhaps like Digirati's mixing desk application built in, so people can browse manifests and pick and choose from several of them what they want to add to the ingest stage prior to processing, which is reasonably computation intensive, and certainly with large collections that's kind of necessary. It would be good to have some sort of integration like that, I think. And in terms of linkbacks to collections, we find, and people who know the presentation API better than me will know this very well, I think, that we find that the link back to a collection in that collection's native viewer isn't always present in metadata, and may be present at different places in the metadata. So that would be interesting to maybe think about whether that is as it should be. Okay, my next use case with a different form of computer vision is matching and retrieval of regions of interest. So in these examples here, these two examples, these are two collections of early printed items, ballads, broadside ballads of the Bodleian, and 15th century printed books, Venetian printed books on the right. And you can see here that associations have been made computationally between different between illustrations in different contexts. The same illustration, the same literal printing surface, actually the same printing block, wooden block, in different contexts. This is the software behind that matching functionality, and those demos I just showed are live, and they can be explored. The software behind it, Vice, the image search engine, is here, and we can see it in action for example, matching buildings, which works very well. But anything on the same plane works well if things are distorted, so kind of complex three-dimensional shapes, and the angle is different. That can be problematic, as it can be if things have an insufficient amount of contrast for this this application. Logos work very well. So here's the Google logo and a variety of news clips in our BBC demo, which is in some ways our flagship demo. It integrates 4 of our classifiers or search engines. You can search by instance with this technology. You can search for objects or scenes using Vic. You can also search for text and for people. And like I say, this is so that the same logo in different contexts and the same clip sometimes, but dropped as different programs, as canned footage, or sometimes the logo itself in different contexts. And I'll just demonstrate that through an example of a project I did with the National Library of Scotland, which has just finished, which is a project to explore their chat books printed in Scotland data sets, which is very conveniently available through their Data Foundry repository with metadata for broad and broadly licensed for use. So I will tab back to Chrome to show that in operation. So moving the Villanova out of the way for a second and going to NLS chatbooks. So what I have here is an image and metadata based presentation of all the illustrated pages. So as a step before this, where we extracted pages that had these woodcut illustrations on, which we used with an object detection algorithm with. We used, when I say we, this is very much the work of my colleague Abhishek Dutta. He's one of the research software engineers at VGG. He, using training examples supplied by me, but prompted by him, annotated a sample of these page images to recognize illustrations. We then trained Google's efficient det object detection algorithm on them and retrieved every page that had an illustration as we defined it. And I can go and I can select a page. I can select a region of interest with this bounding box here. Press search and it retrieves matching items using different publications with the same illustration on. There is a little visualization tool here. I just make this smaller to make that easier to see. So you can see a flip between the two of them to verify that you are looking indeed at the same illustration rather than a close copy, which just happened in this corpus. And I can navigate to the page in which the matched image is. I see metadata, which is actually provided through in various forms by the National Library, but also again have a link back to the NLS. I have a link back to their IIIF environment, their viewers, and I can get the manifest from that as well. Okay, back to my presentation. So the use case for visual matching seems to me that users need to be able to select regions of interest. I mean, you can ingest an entire image and you can search on the whole image. But in this use case, or in many use cases, you need to be able to select a region of an image. That could be selected in, for example, Mirador, which has, of course, a bounding box tool which can be support annotations, links. Those annotations, the coordinates of those annotations and any metadata that goes with them could be submitted to a visual search engine that has ingested images from a manifest using a mechanism similar to what I showed with Vic. And the results could perhaps, I mean, people who know the technology better than I could be in a better position to say this, the results could be stored as coordinates within the manifest. So there is a durable association between matched images, and that may be more efficient than storing large indexes of visual features and the images that have those visual features in common. And since you have those results as coordinates with them, they could be displayed in a IIIF viewer, perhaps as zoom details. So one could imagine a repository like the NLS could present a gallery view of matched illustrations as well as the book by book, page by page view that is the default view of in their current IIIF environment. So you can imagine a kind of, and of course that can include material from elsewhere, and it can provide a kind of catalog view of regions with annotations, but leveraging the same images within the full view. Okay, moving on. I showed this briefly. I showed the use case of image registration and comparison in my chatbook example. I was also on a call yesterday with people from the National Gallery and the Victoria and Albert Museum and other places talking about this in some detail and at a very high level of sophistication in the IIIF Museums group. So I won't say much about this now, but we have this feature of image comparison that I showed in the chat books. We also break out separately, a separate piece of software, the InComp, and here it is in action on, in this case, showing differences in, again, printed illustrations, but also printed text. You see at the bottom here, the bottom of the right-hand bottom of the page, the text containing page at the bottom, there's a typographical variant there, which is of interest to book historians, literary editors, people interested in this case, Shakespeare's folio works. These are pages from. Or you can imagine altered photographs. So this is a famous photograph of an individual who displeased Joseph Stalin, was erased from history. And obviously it's not too hard to see and visualize the difference here, but you can imagine a use case where these differences are more subtle, and this technology could be useful for visualizing them. There is also a use case for automatic detection of difference, so for change detection. We don't ourselves support that at the moment in our comparison tool because the people who we originally built it for didn't want it. They didn't want that kind of decision to be made or to be, they just wanted to see for themselves and verify the differences. And another use case might be conservation photographs. So these are before and after images of the Ghent altarpiece recently conserved in extraordinary detail. I mean, I was on a Turing Institute call, Turing's Humanities Data Science call, I think it was. It may be another interest group actually. But the stunning work, both chemical, physical, and computational in restoring this artwork. So for image comparison, I guess IIIF integration would mean at the back end, the ability to import a manifest, which, as I said, is achieved in some software. You might want to do some preliminary matching if you're simply importing a bunch of images from multiple manifests or within a manifest. You might want to do some preliminary matching to identify candidates worth registering, where the differences are always ones you want to investigate. You might then generate a comparison set of images stored as a manifest, and then perform registration and visualization of the above step. Now, our registration tool includes some algorithms to warp images that are distorted by photography or perhaps variable conservation environments. So we've printed books, paper will shrink variably, pages may be curved in different copies and so forth, and we have algorithms to attempt to rectify that and allow better registration and visualization. At the front end, IIIF seems extremely well suited to this use case. That you can dynamically overlay multiple images, resources in a single canvas, and that canvas can contain annotations which are anchored to it. So I think it's particularly important for defining and registering change or difference, that you're annotating not any one image, but perhaps multiple images that have a feature that is of interest as a whole within, pinned, if you like, to a canvas, if that's correct. It would, in the front end, it would be good to have user selectable visualization options, some of which are already present in viewers like Mirador and things like curtain viewers, but some of the visualizations that we have in our current tool include the blink view that I just showed. We also have a diff view, which is appropriate for high contrast images, where we color code any differences. Last use case, I'm just going to briefly talk about via VGG Image Annotator. This is this Git repository on the left. It's actually by far our most widely used tool. It's a very lightweight tool for annotating images, marking them up, and actually there's a separate branch of it for annotating audiovisual data. many downloads, many stars, many feature requests, bug fixes. There's a great community around VIA. It plugs in very naturally to, excuse me, it plugs in very naturally to machine learning workflows. So on the right is an example of a project we're working on to do semantic segmentation of the printed page. Again, apologies for my background in book history coming to the fore. So on the right is a simple marked up page image, various parts of the page, which we then feed to a classifier. I think we tried Deep Lab and Maskr CNN. Maskr CNN was, I think, the best at this, and we will then attempt to do this to a larger corpus. In VIA, IIIF integration could include augmenting its existing abilities to input and output JSON data. So the annotations, either annotations on file or annotations on region, annotations, there can be an arbitrary number of annotations for a region or a file. And we support standard machine learning output format, input and output format, so Microsoft Cocoa and Pascal, POC. But we could also, I think, perhaps input and output OAC annotations and perhaps manifest in the resources. So again, it's a question of simply providing a link to a single manifest, you get everything, and then you do your annotations, and then you write them back out. That is the kind of convenient augmentation that I think would be really good to discuss the details of with people on this call and beyond. So I'm just kind of looping back to the slide that I started with, and sort of conclude. We invite any and all interactions around what we offer in relation to IIIF, critique use cases, co-development, and discussions about standards that are coming out and how machine learning broadly defined can maybe contribute to or benefit from those standards. And I will, at that point, leave it, turn back to you to begin that conversation. I'm hoping I've finished screen sharing. Is that correct?
Yep, we're back to normal.
Yep.
Okay, wonderful. And there's some comments in the chat I see already, so I'll bring those up. Okay. Wonderful.
So I had a question straight off, Giles. You said that some of the tools already supported IIIF integration. Is this in as much as you can just drop a manifest URL in and then the tool works? It just pulls the images down. I mean, I know you said that things didn't work straight away with the image API, but I presume it takes the static image links and
That's correct. It takes the static image links and it downsamples them to 500 pixel width as a defense mechanism about the explosive ingest of huge amounts of data we can't cope with. The code I showed us on GitHub and Ernesto provided, I'll give you kind of more detail about how it does that. There are, of course, other kind of standalone IIIF, get me all the images from manifest tools. And perhaps there are better ways we could be doing that. But yes, that is really the kind of baseline level of integration that we have at the moment.
You may have mentioned this, and I may have just missed it. But does that extend to accepting IIIF collections as an input? Which well, I'll leave it there. Yeah. Yeah.
So the Villanova Digital Library example I showed is a collection, and that's what makes the fact that it can cope with collections is what makes the spec and our integration handy for workshops and classes in particular, because yeah, you can ingest a manifest that contains a single book. There aren't too many books that are as visually diverse and engaging. I mean, there are some, richly illustrated books that are useful cases for image classification. But yeah, the fact that we can ingest a whole collection is nice. Although I do remember a conversation with Ernesto Coto saying that the way that collection URIs was formed was not entirely what he would expect, and he has to do some work with those in order to get what he needed from them. I'm sorry, that's a very frustratingly vague non-software engineer's description of his disquiet. But we are able to work with them. And it, like as I mentioned, it does require a bit of care when one selects a collection URI about what's going to happen when you press ingest, because collections can be colossal. I mean, you can ingest all of the Bodleian digital Bodleian at once, I think. If not digital Bodleian, then certainly some other large institutional collections. So I find the kind of the visual browsers, things like Durham's Manifest browser, and I know there are others, incredibly useful for looking, just peeping inside what is in a collection. And then if there is a URI for a collection and not just a bunch of URIs for each particular book, then that's appealing. There's some comments from. Oh, there's some more comments in the chat. So you go down. Okay, yeah, you flag up. Yeah, Biblisua collections in particular are really interesting. Yeah, I enjoy sort of delving through those. Some discussion between Anne and Matt about the content states API, which I think Matt, you're doing a lot of work on, aren't you? And,
yes, but yeah, Anne flagged that up. But that's really a standardized way of drawing attention to content. So if you want to share a piece of content, or you mentioned, for example, once you've done your kind of region of interest identification, being able to take you to a viewer that has that as the kind of focus and so on. The content state API is geared towards solving that problem.
is that the kind of use case you had in mind, Anne?
Yeah, I mean, Matt can speak towards the development of content state a lot more than I can. But I was particularly thinking, you showed the results of matching the frontispiece on all those chatbots. I think Lynn did a demonstration a little while ago. I can see if I can find the link to his site about kind of bookmarking images and exporting them, I think, to a Pinterest board of all things. But a way to sort of basically just collate, here's all these images and struck down to a very small size. But there's no reason why that can then become a manifest in and of itself.
Mm-hmm. Yeah, I mean, there's this sort of use case, isn't there, for kind of linked data, that if you can discover this association, linked data, any kind of relationality, essentially, you discover this thing, you may need to store it then. And that's something libraries, cultural heritage organizations are very good at discovering what things have in common in different locations and making an association that is self-referenceable. How do we cite the fact that in the existing literature, how do we cite the fact that two items have a relationship? We normally cite both things and have some text that that describes that relationship. But if we can kind of firm that up, include that annotation, but also have an explicit link to both those things, then that's very useful.
Yeah, I mean, content state would give you that, I think, or it would, at least would give you the ability to have a nice portable kind of brief format that allows you to link directly to a manifest or a canvas or a section of a canvas or multiple sections of multiple canvases and multiple manifests, so that you could, for example, if you're comparing two illustrations from these chapbooks, or two illuminations, or the hands of two different scribes in two different manuscripts and so on, then content state gives you a lightweight way of doing that. So it's a useful way of passing that information around.
I'll have a look at the spec. And one of the things I'm particularly interested in my work is not just the relationality, but the direction of relationality. So such and such is a copy of something else, or this instance is later than the one before. And we know this because we can see that the block of wood that made the illustration has gotten chipped. But we don't know this because, so we probably need a way of flagging up that we don't know what the relationality is, but there is a relationality. And there's looser kinds of semantic association that you get from the sort of cat spotting type applications that so the example of Vic that I showed, that do these more kind of loose iconographic categorizations. The iconography is frankly a bit overselling its capabilities in terms of image categorization.
Maybe this is a connection you have or haven't thought about, but I guess just thinking about some of these, sort of more abstracted aspects, qualities of materials and connections to draw in on the linked data front. It seems like a lot of these tools are geared toward and really useful toward sort of local development and institutional contexts. I wonder if you have done any work or have talked about doing work with things like Wikidata properties. So there's sort of some nascent work in adding manifests and regioning and things like that to the Wikidata universe. And it seems like that's not the only place you could register connections like that, but it might be a useful place, and it might also be a way of kind of advertising the possibilities here. Yeah, I don't know if that's come up for you folks or not.
Yeah, a little bit. So we are in a consortium with and others that's hopefully going to look at this if we get funding. So Wikidata are a partner on a project that involves lots of organisations and ourselves about forming an enlarged collection of UK visual art. And Wikidata is an obvious place to store those associations. I think in general, as an engineering group, we tend not to get too deep into the weeds of domain-specific metadata, although Wikidata is sufficiently broad and general that I think we ought to, and like most methods-based organizations, I suppose, or research groups, we're a bit leery of spending time thinking what we consider to be too much time thinking about. I mean, that's not entirely true. I mean, we're very interested in data quality, including provenance. So we want data to be reliable. But, if we've identified a bunch of objects, individuals in something, then the obvious next step for a partner we're working with, Culture, and the British Library is an example of this. We did some work finding British politicians in Russia today using a combination, Russia Today footage, news footage, using a combination of facial recognition and speaker identification, also reading the text of the Karen. And we have names that are in a kind of internal data bank, but the obvious thing to do is to attach Wikidata properties to identifiers to those names. It would be Wikidata in the case of those individuals. Other domains, other standards are more relevant, of course, but with linked data, you can have very many of those. And even Wikidata points to many of those. I'm just going to scroll back down through the chat.
I had another brief question for, you mentioned about the kind of potential for output of the matched images as annotations to feed back to the original manifest. Could there also maybe be a use case for dynamic generation of manifests based on a search? So you might ingest several collections from different places and then run a search to say for Apple and have back as the output actually a IIIF manifest that contains all the canvases from within those collections that have an apple in the image.
Yeah, that's exactly how I envisage it working, and I kind of suspect it a little bit kind of rather clumsily in my thoughts on the image comparator. But yes, provide a description of a new item, a digital scrapbook, if you like, or gallery view of all your apples from all the things you've looked at. I think that's I mean, you want a kind of light way of storing that. I mean, there's no point. I mean, there is some point in holding local copies for posterity everywhere and for unforeseen circumstances. But if I'm a scholar of apples and arts, it's a much easier proposition to say to my institution that I want to build a catalogue, for whom I want to build a catalogue of apples and art. All you have to do is host a bunch of URIs, and you have to have a viewer as well. So you have to provide a IIIF viewer, and I'll provide you with a manifest containing all the apples that I found. We'll pull those in from wherever they are, display them locally with my commentary. I think collection managers, digital collection managers and digital infrastructure managers will feel quite happy about that in terms of sustainability. I mean, you will get broken links, as I showed in my Villanova example, which I haven't yet investigated. I haven't seen those before. I imagine things have moved at Villanova's end, as they do.
I have a quick follow-up question to that. Probably revealing my ignorance on IIIF. But Giles, you had mentioned how it's problematic, and I've had this problem as well, when manifests don't link back to perhaps the original institution record, catalog, or whatever of the item in question. If you were able to do what Mike suggests, and let's say create a manifest based on the results of all the apples, it's one thing to be able to link a manifest back to an institution catalog record or something, but is it possible in a IIIF manifest dynamically created like that to have each of those apples contain a permalink back to the original manifest that they came from?
Yes, yeah, you could do that. You could also link back to the original homepage or any other kind of life cycle information that's associated with the manifest. There's no, in the IIIF presentation API spec, you can kind of attach that data either at the manifest level or at pretty much all of the other levels lower down. So you could kind of float in the information that you've pulled from the manifest and attach it to some canvas that you've put into some composite dynamically generated manifest. So there's certainly the specs certainly allow you to kind of carry that information with the canvases, even if they're no longer in their original context. Obviously, you have to design your software to do that, but the specs certainly allow that to happen.
I mean, yeah, I did highlight, it's one of those things that's surprising to me once I started looking at the contents of manifests that we'd ingested. Sometimes there's a link back, sometimes there isn't, sometimes it's in different places. And, that image has come from somewhere. So it's surprising to me that that's not presented. It may be our fault, though. It may be the way we're passing the manifest, we're not finding it in the right place, and we need to look harder at that. I mean, the level of integration we have is, it is decent, I think, given the time that was put into it, which was not huge, but it could certainly be improved. The other thing that I'd be interested in people who are deeply versed in the spec, their thoughts on is, why is it so often hard to find a manifest for an item that you're looking at in front of you, or a collection? I would want there to be a button saying, can I please download, or can I have a link to that manifest? And I don't always, sometimes I don't often see it.
I mean, a lot of the IIIF viewers can provide you with that. So if you're using the Universal Viewer, or I think Mirador and some of the others, they will provide you with a way to get access to the manifest. But in kind of institutional discovery portals and so on, that's much more a UX choice that the institution has made, whether or not they want to expose it, I guess. So yeah.
So I want to say University of Texas at Austin, in their catalog, has the manifest URIs.
Also known as, what does that IIIF button actually do? Results may vary.
Just that's the default group. There's issues.
Sorry, and that's just what I was going to say. Is that's a very succinct way of describing the animating, like the charge for the Discovery for Humans group, which is maybe a cheeky term for it, but it was basically meant as it's the technical specification group that Matt works on is solving kind of URI and other spec things that problems can solve, but the UX aspect of exactly what you said. Some people use the icon to link to Mirador. Some people use the icon to link to a manifest. Can we, we can never enforce it across the community, but can we use social pressure and best practices to deliver, a best experience that people will align with? So that's very real. And I guess to a previous point, or you're sort of asking for ways to connect. I think that's a great one. If there's connections you can make to Discovery for Humans. Another one, I sort of wish Glenn or a few others were here, but I guess I'm curious to know if maybe there's a place for a working group or just an ad hoc group, kind of around this idea of grouping, for lack of a better term, like machine learning outputs, or like cross collection annotations and things like that. I know it's possible, there's no question about possibility, but maybe what we're lacking is a recipe or just sort of a cohort model of the best ways to do it, to make it the most useful for different places. Because I think of places like, I don't know if you're familiar with the curation viewer from the Center for Open Data and the Humanities out of Japan. It seems like they're doing a couple of similar things and kind of outputting some similar things. I think there's a CLAMS group out of I think Brandeis, and working with WGBH in Boston. So they're doing audiovisual machine learning, but it's a similar sort of thing where they're just doing regions and time codes and outputs of things. And I wonder if maybe now is the point in the game to kind of get a cohort of folks working on things like this to align on the best, most useful way to do it, even if it's just to create a recipe.
There is a machine learning group in the IIIF Slack, which I don't think has that much activity. But I think that was the thinking behind the creation of that. Was, looking at it, there's not been any traffic for over a year, but I think the gist of that was to provide a place for kind of discussion of all of these things, whether it's computer vision or natural language processing or these other things. So it might be worth reviving that in a more active way. I think there's definitely a place for that.
There's people at the Turing who are talking about this, and then there are people at the Turing who are talking at the IIIF conference and a number of other AI and IIIF talk schedule, which is very exciting. So I think, and I had heard about the IIIF curation platform, so thanks for that link, Josh. And if you want to provide links to CLAMS group doing audiovisual material, that would be very good too. Or perhaps I can find that easily enough myself. So is one of the, I understand I mean, there's lots of things that cohort could talk about, but one of the things would be the retrieval of information from manifests in a way that was amenable to machine learning systems. So we have these bespoke JSON standards for feeding data sets to classifiers, one kind or other. There's COCO format, there's Pascal VOC, there are others. But if we can just leverage existing standards and community standards and get what we need from that and give back, particularly something that has a classification run over it that is then readily viewable, interrogable, and readily reusable, then there's real benefits. Because a lot of the problem is that even if we are giving away tools, I'm having a very parochial VGG view here, so we can give these tools away, but they're still, even though they're open, they're still black boxes if they aren't part of people's native workflows. They have to be right there. The classifier has to be right there in the environment that people are working to catalog, annotate, classify, publish. Otherwise, it may be on the other side of the world, really. So I have spent time talking to content management system vendors who are interested. They want to, of course, know the use cases. So it's good as well to talk to people who have content, have specific tasks. And very often it's not the things that are the most, well, sometimes it is. Sometimes it's the things that are kind of state of the art in technical terms. But the things that catch people's eyes in collections are registration, deduplication, retrieving things that would otherwise, they understand the use case, they understand the task, but it needs to be done, or it can always be done more quickly. So we've done some work with several organizations for simple deduplication using visual features of resized and cropped photographs. There are hundreds of thousands. Everybody has duplicates. I know I do on my own desktop, and that's the kind of thing I think that, when integrated into people's native ways of working, can really be a game changer, and leave them time to do perhaps more interesting things. Oh yeah, Pixplot you mentioned. Yeah, definitely, absolutely. Yeah. Pixplots, nearest neighbors, real neighbors. The folks of the say deep visions. It may not be true. Lauren Tilton and Taylor Arnold, their group, their project, which is AI for audiovisual search. Lots of things going on. In terms of adoption, I mean, people here might have a view on this, but it seems like we're at a point where some experimentation has been done with machine learning, with computer vision, and the next step is to put things into production. But exactly what and how is the discussion that's being had. And certainly IIIF is something we need to be thinking about from our point of view if we want to do these things.
Yeah, there's only a minute or two left, and I don't know if someone else has a last comment, but I won't put you on the spot, but I'm going to think more about this, and I wonder if, I just put this in the chat, I wonder if a cross-pollination with the AI for Lamb community might also be useful, just to get this on people's radar, so more people might make use of IIIF than, if it's just within IIIF, it's already, people already sold on it, whereas, so I may follow up and see if we could get a little cohort of folks going, and I won't put you on the spot to see if if you're in on it, but I'll follow up.
I'm already sold, Joe. I mean, I've talked online to the AI for Lamb call, and they did a number of workshops. I gave a workshop at the BNF that Libba hosted, and so did people from the Turing. So there's Turing people putting together a library carpentry package on computer vision. Actually, not just computer vision, because they're doing NLP as well. But yes, definitely. And I think AI for Lamb actually, very much had the IIIF community in mind as a model for how to grow. And despite my repeating some of my colleagues' feelings that things are a bit fuzzy, of course, you're a model in how to grow in terms of allowing standards to be implemented locally and for people to find uses for it that are appropriate for their materials. So. I think that we share ourselves, a notion of being as generic as possible, which means it's up to other people to sort of build the interfaces and do the implementations. But we do more implementation actually as demos and test cases than some research groups. One of the problems we face, though, actually, and this is what I would say to this community, is that people don't necessarily always know that they can approach groups like ours with their materials, with their use cases, but we're definitely open to those approaches. We're really interested in these materials. We like the work that's going on already with IIIF. But we ourselves, we need to know what the use case is, I guess. And as IIIF broadens out a bit, perhaps that'll kind of bring more to the attention of computer scientists.
Excellent. Well, I think, yeah, this is great. We have some next steps, at least a few.
I'll leave that to you, Josh. You'll make the approach with Neil, perhaps, and suggest, yeah, okay, wonderful. Yeah.
Amazing. So it looks like we're just a minute after time. Giles, thank you so much. That was a wonderful presentation. You guys are working on so much interesting stuff. Thank you everyone for attending, and we will meet again in 2 weeks for another community call.
Thank you, everyone. I got about 3.5 pages of notes from your presentation and the discussion, Giles. So if you want, if you want to have a quick flick through just to make sure I didn't horrifically misrepresent you in any way.
Yeah, if you want to check spellings of any names or something, then I'm happy to pass them. Are they in the notes document, or are they elsewhere?
The community call notes
Right,
document.
I'll have a look through them, yeah.
As linked.
Thanks, everyone.
Yeah. Great. Thanks all.
Thank you.
Nice to see
Bye.
you.
Bye.
Bye.
Bye. Thanks all. Bye.